Good morning, students. Welcome to 8th class Physical Science. Now, in this class, we discuss about topic observing the variation of friction. Okay? Observing the variation of friction. Okay. Let us consider a heavy box. The heavy box is placed on the floor. Okay. This is heavy box. This box is placed on the floor. Now, this box is pushed by you. That is, we can apply certain force on the box. Okay, this is that applied force, capital F. That capital F is indicate applied force by you. We applied certain force on the heavy box. What happens? We observe that this box is not moved. Why? Because of the force of friction. So, the heavy box can also apply the equivalent force to opposite to applied force. So, this F is applied force in which direction? That is to west direction, and R, that is that right direction. But in case of the heavy box can also exert the force against to applied force but in opposite direction. So this is that the friction force offered by heavy box. Here the applied force and the friction force offered by heavy box, these two forces are equal in magnitude but opposite direction. That's why we observe that the heavy box is not moved. Okay, this is the first case. Case 1. Okay, next one. In second case, we can apply more force on the heavy box. That is, we gradually increase the applied force on the heavy box and push it. What happens? We notice that this heavy box is not moved. It does not move. Why? Because of the friction force is also increased. These two forces are equal in magnitude but in opposite direction. That's why the heavy box is not moved. Okay, in case of second case, we observe that this box does not move. Why? Because of applied force and friction force both are equal in magnitude but in opposite direction. That is, increase the applied force on the heavy box and also increase the friction force offered by heavy box. That's why the heavy box doesn't move. So, this is a static friction static friction, it will cause for this heavy box is not moved. Okay, when we have to apply certain force on the heavy box, it does not move because of a static friction. Static friction is a self-adjusting force. It is a self-adjusting force. Static friction is a self-adjusting force. That's why the heavy box doesn't move when we applied certain force on the heavy box. This self-adjusting force, static friction, is a limit. But this static friction is a limit. Next one, in third case, we can applicable more applied force. We can apply more, like greater force. In third case, we can apply greater force on applied heavy box. What happens? We can apply the force on the heavy box to overcome the limit of static friction. We applied the force on the heavy box to overcome the limit of static friction. Static friction is a limit. It is a limit. To overcome the limit of the static friction, then start the heavy box in motion. Start in motion. Okay, the heavy box start in motion when does we apply the force is overcome the limit of static friction. At that time the heavy box start in motion. Okay, students, if any body it will come to the motion to overcome the limiting of static friction, at that time the body it will come to rest or it will come to in motion. Okay, students. Okay, in first case this heavy box doesn't move. Second case doesn't move because of we have applied the force and the friction force offered the heavy box. These both forces are both equal in magnitude but in opposite direction. That's why case 1 and case 2 the heavy box doesn't move. Why? Because of a static friction. The static friction is a self-adjusting force, but this self-adjusting force is limit. When we can apply greater the force on the heavy box to overcome the limit of a static friction, then the heavy box start in motion. Okay, next one. Let's go to that. Next one, let's go to factors affecting friction. Next one is factors affecting friction. Factors affecting friction. Okay, factors affecting friction. Okay, first one is effect of roughness. Effect of roughness. Effect of roughness on friction. Effect of roughness on frictional force. Frictional force. Okay. What are the factors are affecting on friction? First one factor is a effect of roughness. Effect of roughness on frictional force. What is the relation between the roughness of the surface and frictional force? If roughness increases, what happens? The frictional force is also increases. The frictional force is also increases. If roughness of surface is increased, what happens? the frictional force is also increases. Okay, if the roughness of a surface decreases, the roughness of a surface is decreased, what happens? The frictional force is also decreased. Okay, what is the relation between roughness and frictional force? If roughness of the surface increases, then the frictional force is also increased. And that is the more frictional force is offering on roughness surface. Okay, look at it. Okay, we conduct a small experiment. In this experiment, we set up an inclined plane. Okay, students, this is an inclined plane. A wooden boat is taken as an inclined plane. Okay, next one, we have to find out any point on the inclined plane. A is a point. Where is it on the inclined plane? Now take a pencil shell or ball. Now take a pencil shell or ball. It's placed at the point A on the inclined plane and it's leave it. What will happen? The pencil shell is moved down on the inclined plane, and its motion and it's covered certain distance on the floor from the bottom of inclined plane to up to it will come to stop at certain point. Okay, students. Now we can measure the distance covered by the pencil from at the point of bottom of inclined plane to the point where it will come to rest. Okay, now we can measure the distance. Okay, second case 2. Now we take a cloth. This cloth is spread on the floor. Okay, this cloth is spread on the floor. Next we have to make it careful without no wrinkle this cloth. We make sure that there is no wrinkle this cloth. Okay, next again we take a pencil shell is placed at the point A on the inclined plane and raise it. What happens? The pencil shell is moved on the inclined plane. Okay, moves on the inclined plane. After it will come to rest at certain point. Now we measure the distance between the point of at bottom of the inclined plane to the point where it will come to the rest. Okay, next one, the same experiment is repeated on the glass surface and marble surface. Okay, in all cases, the distance covered by a pencil shell is equal or not. We say that the distance covered by the pencil shell is different on different surfaces. Okay, in case of the distance covered by pencil shell is maximum on glass, marble or smooth surface or marble surface or glass surface, it's covered maximum distance. But in case of the floor on the cloth, it can travel minimum distance. Why? What is the reason? Okay, we will look at many number of surfaces. All surfaces are their appearance to plane surfaces. Many of the surfaces are plane, but there have many number of irregularities. Irregularities means moves up and downs. They are present number of where is it on the plane surfaces. Okay, the distance covered by this ball is decided by the surfaces of both bodies. Okay, the smoothness or the roughness of the surfaces of the floor and the surfaces of the pencil shell. These two surfaces of bodies are to decide the distance covered by the pencil shell. So these plane surfaces are, they have a number of irregularities. Irregularities means up and downs. Okay, next one, the surface of that two bodies, their irregularities on them, they are interlinked one to each other. These irregularities are locking one to another when two surfaces of bodies are contact in them. For example, here the pencil lead, the surface of the pencil sill or the surface of the ball and the surface of the floor. These two surfaces of objects are locked one to another. Why? Because of irregularities are present on them. So that's why who apply the force on the book, on the pencil cell, on the heavy box to overcome the interlocking or irregularities, the interlocking of irregularities of both surfaces to overcome at a time to start the body's motion. So, if irregularities or increases will greater than frictional force. Understand? If the frictional force is the greater, when if the irregularities are more. Okay, these irregularities are to decide the force of friction. If increases irregularities on the surfaces of both bodies, what happens? Increase in the frictional force. Okay, so that's why the cloth surface is offering high frictional force. That's why the pencil is covered minimum distance. But in case of a glass surface or marble surface, the offering of a low frictional force. That's why it can travel longer distance. Okay, friends? Okay, this is a reason for that the motion of a bodies will come to the rest of a certain time interval because of the irregularities on both surfaces of the bodies. It will cause for the force of friction. The cause of force of friction, the motion of bodies will come to rest. Okay? In the next class, continue. Thank you.